Welcome to Green Cell's monthly webinar. We have a webinar on varied topics every second Sunday of the month. We will be starting our webinar shortly. As we wait for everyone to join, we have a short video playing which speaks to our activities and events. If anything piques your interest, do reach out to us and join us. And also follow us on Facebook, Instagram, and on our recently launched website, and stay informed of our events. Good afternoon, everyone. Thank you for taking time to join us today. My name is Lata Krishnan. I'm a volunteer with Green Cell, and I will be your host for today. We also have Sandesh with our presenter Shashi in his garden. Green Cell is a volunteer-run nonprofit organization. We are very passionate about raising awareness of human-created environmental issues and promoting conscious consumerism. As a part of our efforts, we run several community projects such as cleanup drives, food rescues, and recycling campaigns. Our objective is to help everyone go green and incorporate small and big changes in our daily lives, which will go a very long way in reducing our negative impact on the environment and the natural world. Simply put, our aim is to help everyone go green. We conduct regular webinars on varied topics ranging from composting, growing your own food, recycling right, hydroponics, sustainable energy, and several areas where we can make changes to help reduce our carbon footprint. These webinars are held on second Sunday of every month. For next month's webinar, we have Pankaj Rajankar, who will be presenting about recycling right on 11th of July at 3 p.m. Now I want to introduce our speaker today. We are in Shashi's garden today, and we chose this location as this is one of the venues Shashi had automated. Greensill has been conducting monthly webinars on varied topics, and given it is the season of planting, we have been actually planning a series of webinars that will handhold you on your journey in the garden throughout the summer. As a natural extension to our previous webinar, today we will learn from our expert in this field about automating our garden and how to efficiently move the water that we collected in the rainwater barrel to your garden beds. Our speaker today is Shashikant Velam. He is a practice leader and specialist in IT consulting at IBM. Gardening that was once his hobby has become his profession. He is a techno farmer running multiple farming companies across USA and India. He owns Vallem Vaari farms in Cumming, Georgia, where he grows organic produce and sells them commercially to Indian stores and to customers directly. He is very well known in our garden community and always willing to serve them, and has graciously agreed to share his knowledge with us today. It gives me immense pleasure to welcome Shashikant Velam. Just wanted to go over a few housekeeping rules. Before we start, I would like to go over some rules. We will have all our attendees on mute so that we can hear Shashi clearly. If you have any questions, thoughts to share during our presentation, please use Zoom or YouTube live to send the messages. Our volunteers are monitoring the chat windows and will get to all of your questions and will take it to Shashi. He will try to answer them either during or at the end of the presentation. If you have any questions after the session, please email them to greencellatlanta@gmail.com. Once again, a very warm welcome to our speaker, Shashi. Shashi, the floor is all yours.
Thank you, Vita. Hi, everybody. Can you all hear me?
Yes.
Okay. So thank you for this opportunity, Greencell. I've been doing the drip irrigation for quite some time. It's been many years that I've also run a company back in India to help people set gardens. So my main interest with the drip irrigation is to ensure that monotonous activities like watering the plants is automated. One of the biggest challenges is the regular methods to apply water, because it's better for our plants to have regular water on a daily basis for a specific duration and on a specific frequency. So we can do it manually, but at the same time, when automated, it really saves a lot of efforts. So that's the reason whenever I go, whichever garden I set up, I completely automate them to ensure that they don't need to spend any effort in watering. The effort saved from watering can always be used for other activities, which are like pest management, putting up the right plants, and many other valuable activities within the garden. So basic principles of drip irrigation is you have source of water that could be your city water from the faucet, or even from the water collected in the rain barrels. The idea is to mobilize that water close to your plants and then get it to your plants. So whenever you have this situation of water from different sources, there are different devices that could be used to help you move the water from one place to another. We will talk about the basic systems. By the way, most houses, I would say 95% houses in USA have the irrigation systems automated, especially for the lawns. When you say lawn, it's sprinkler systems. Now, every house, even 20-plus-year-old houses, will have sprinkler systems that you would find in your garages. It would be called as either Rainbird or Orbit or Hunter. Some of these systems you would find them where on a periodic basis it starts the sprinkler and waters your lawn. So the irrigation system that we are talking about is similar, but at the same time it doesn't sprinkle the water. It puts the drop by drop into the locations that you need. This would really save you a lot of water without evaporating it, and at the same time it's putting the water right on the soil but not on the plants. Water sprinkled on the leaves is not good for the leaves because it may end up forming mold or any kind of diseases. especially if you're watering in the evening time. So it's always advisable if you're manually watering to water it early in the morning so that even if there are any droplets on the leaves, it gets evaporated with the sun. So with that, let's look at a few aspects of drip irrigation systems. So here I have, this is the main component of the drip irrigation system. It's the size of, I have taken a small piece of the pipe. This is called the half-inch pipe. So throughout this discussion, we will have few terms called half-inch and 1/4 inch. This is the half-inch pipe, and this is the 1/4 inch pipe. So these are the pipes that are helping you bring the water from your faucet all the way to your drip systems. So this is the instrument that would help pick up water from your faucet. This is the female thread. It gets onto the male thread of the faucet, and your drip, the pipe will get attached to this like this. I'm not going to push it in, otherwise it will not come out. And once you have the pipes going to the location where you want the water, these are the smaller pipes that gets into the bigger ones using these adapters. This is how the adapters are connected. Can everybody see me?
Yes, Shashi.
Okay. So I will show it on the live demo how I'm going to do this. So these are called the adapters that would get inside into the main line and then gets attached to this one. I'll just insert this and show you that. So this is a device that you use for punching the holes. Do not punch with the screwdriver or any other things because the hole will not be precise. This is mainly made for punching a 1/4 inch hole. You need to hear the click sound so that it makes the precise hole. And then you could insert this is how we are inserting a 1/4 inch. This is called 1/4 inch barb. This barb gets inserted into 1/2 inch tube, and then you connect your tube into there. Using this twist action, you're able to insert it. So this is where you get the water out. This can get onto your beds. I'll show you how it works. At the same time, this is the tube that you see, which has emitter every 9 inches, which means the water that gets inside will drip out of these emitters at every 9 inches. These are highly engineered emitters where it regulates the pressure. It will hold the pressure irrespective of the location of the tube. It will emit the same amount of water from this emitters. So you will see that every 9 inches it has the emitter. So the idea is wherever you want the water, you can just twist and turn this tube all across and then it will emit water. So we are going to make a connection like this. For example, this is very good for the trees or a bed. So whenever you have a bed, you're going to put it on the bed and then you're connecting the other end of it here. Right? So the water is coming from the faucet, getting inside this tube. There will be a closure here. This is just a test. That's why we're showing this open. And water gets inside this, and it gets onto the bed here. So we will show you the real working scenario here. This entire system is operated by a ratio controller. Ratio controller is something that would connect onto internet, look at your weather conditions, and if there is a rain, it would stop watering because there is no need of watering when it rains. So it has all that intelligence that will help you save the water. We'll show you the controller in some time. Can you guys hear me?
Yeah, I can hear you now, Shashi.
Okay. Okay, I think it's going to mute by default, so just let me know if you're not able to hear me.
Yes, absolutely.
So you're able to see the app. This is the app. This is the ratio app. It has stopped the scheduling yesterday and day before because there was enough rain, and today it's scheduled for the watering. And now I have switched it on automatic manually. Now I'll show you the rings that I talked about. So these are the rings that I have made, and this is a 100-gallon bag. So I wanted to have water across the circumference of the bag and also in the middle. So that's why I made 2 rings, and then I have water coming from the tube. If you look at a tube here, just come over here. This is the main half-inch tube that's coming from the faucet, and I have an adapter that is taking off from here, and it gets inside the bag. And in the bag, we have these 2 lines of 1/4 inch tubing with 9-inch emitters. So this particular bag has 3 circles, and both the circles would be providing water to the bag, so that every 1 square feet it's getting water. That's how I use the 1/2 inch and 1/4 inch tubing. So we also have spider emitters where, wherever there are bags, in this scenario, it's a bag. I wanted water going from the tube. We have an adapter here, and it gets into this tube. And I wanted to hold on to this place. That's why you see this is an arrow. You see the droplets. This arrow gets inserted into the soil in the bag, and it provides the water exactly at the roots. So this method is for the bags. So we have looked at 2 different methods. One is the grow bed, wherein you have the complete circumference of the bag is watered at every 9 inches. This is spot watering. Wherever you put this arrow, it would water at that location. I've used the same thing for trees. This scenario, this is the apricot tree. This is a 10-gallon bag. I wanted to have little more water compared to the normal bags. And so I have inserted 2 of these spiders here. Rita, can you hear me, right?
Yeah, I can hear you, Shashi. Yeah.
Okay. Yeah. Sometimes it goes on mute, so just.
No, I can hear you.
This is how I use. Okay, perfect. So this is how I use for the trees. So here you can decide if you want it for 1 emitter or the 2 emitters. Here in this case of a tree, I used the 2 emitters. Now, the tubes that are coming all over, I have run about 200 feet of tubes all the way from my from city water faucet all the way across the garden. So wherever I need a connection split out, this is how I use this. This is called a T-junction. So we have water coming through this pipe, and now I wanted this water going to left side of the garden and also to the right side of it. So I made a T connection here. So this T connection has an adapter. This is called the T adapter that goes, one line goes to this side and the other line goes to this. And here you will also see a elbow joint. This is typical plumbing joints, but this is meant for irrigation systems, and these are the special adapters for this. This joint would help the tube, instead of taking a sharp bend, it will help you, the tube, put the water through this corner. Without this, if the tube gets folded, the water pressure would increase and then the water will not pass through properly. And we also use these pins to hold the tube in the place. Otherwise, you will see the tube rising in this model. Right. So the basic principles are 1/2 inch tubing and 1/4 inch tubing, and the barb connections that comes out of the 1/2 inch to 1/4 inch. So we have looked at, this is the typical tub model which I have used. I've used 2 connections here because this is a larger 15-gallon pot and I wanted more water to go inside this. And you will see that every grow bed has a similar model of 2 circles here. You can see this here. In this grow bed, I have planted brinjals, so around it. So I have used two connections, two circles, and both of them are connected to each other. You will see the joints. So far we looked at half-inch tubing and 1/4 inch tubing with multiple adapters, which is T-joint and elbow joint, both for half-inch and 1/4 inch. Any questions so far?
Let me check. You can continue, and then we can always get to the questions. Yeah.
Okay. All right. So maybe when we are here, we will also talk about the grow beds. Instead of planting, I mean, many questions have been that, why do we, when you have enough soil, why do we want to plant in grow beds like this? The soil here is not in our control. So I would rather prefer to have my own soil where I can do some blending in terms of compost and sand and topsoil. So I brought this soil at the same time. Instead of mixing the soil into the ground where it may erode with the rains, I've created this grow bed. These are about 150-gallon grow beds, wherein the complete soil is contained within this system. So it gives about 9 inches of depth to the plants, and plants will have right ingredients that are required. So if you look at, I have about 21 beds so far here, and I have different plants across all these beds. Most of this side is a vegetable bed. And all the beds across, including the pots, I have the drip irrigation setup. And we can also look at the irrigation system where we have a different variety of pots.
Shashi, there's a question on from Zoom. Archana is asking, if I have 5 beds of size 8 by 4, do I need a 2-inch pipe to water these beds, or is it 1/4 enough?
No, 2 inch to 1/4 is a huge variation. 2 inch is only for commercial agriculture. So standard home irrigation is 1/2 inch. It's just 1/2 inch. 1/2 inch from the faucet of the city water, you will connect a 1/2 inch, and then to the individual pots, you will make a 1/4 inch.
Okay.
All right. So in this model, I have a line of pots. So instead of making one spider for each of them, I have run a 1/4 inch emitter tubing. This is called emitter tubing. It has holes every 9 inches. So here, whenever I switch it on, I will have the water at every 9 inches. I'm going to switch on one more time. So you will see a little bit of delay because it has to start all the way from the main connection, and it may take a minute or two for it to reach to this place. So the idea is that you will just run through these pots, and everywhere there is a hole, you will have the water getting dripped down to that particular pot. So this would avoid our material cost and helps us water every pot in this. You can use multiple methods. You can even have one spider emitter for each of them. So you will see the droplets for each of every 9 inches here. So the moment, once you have this setup done, once you are able to master how to connect a 1/2 inch to 1/4 inch, it's up to your creativity on how you want to run this pipe, because it's very easily, you can just run it. It just loops around. It's just a flexible pipe. So you can run wherever you want, and you can have the water at that location. If you want to have a water at the secluded locations, that's where you can use the spider emitter that I've showed that I use for the trees. So let's look at the initial connections. When we're here, we will look at the controller. I've kept the controller in the basement. This is the ratio controller that would help you control the entire walls. It can go up to 8 or 16 zones, but I have used just 2 zones out of this. This gets connected to your Wi-Fi, and from your Wi-Fi, you have complete ability on your internet, which means that you don't need to be at home to operate this. You can, as long as you're on the internet, you'll be able to operate this controller, because through your Wi-Fi, it gets connected to your internet. And also, you don't need to switch it on and off every time. You can just connect it and then let it sense the rain based on the internet weather channels, and then it would water your plants. You can also schedule it on a periodic basis, let's say every day, 7 o'clock in the morning for 15 minutes, and stop when it rains. So it has all these intelligence by itself. Only when you want to change the setup in terms of schedules, that's when you need to access the controller. Like this example, when I wanted to show you the irrigation system, I wanted to manually switch it on for 3 minutes. So that's when I use the app and then open it up. Otherwise, it's completely autonomous, and then it will handle the watering by itself. So we look at the solenoid valves that are used. Basically, whenever you have a faucet, you're opening a faucet to let the water out. The manual action of opening and closing the faucet is done by electronic solenoid. Solenoid is a simple principle wherein you pass electricity to the magnet and the magnet turns on and off. So the same principle has been used. And these are this solenoid. Water gets as an input into this. It gets into 3 channels, and each channel is controlled using the wires into the controller that I have shown. And just by operating the solenoid, it's opening and closing the particular valve. And so, yeah, you can go out. Yeah. So I've also used the irrigation system on my deck. So for some of the plants, and you will see the, switch it on. So these are the group of plants. So I wanted the watering to be done for the group across. So I have used a small sprinkler. It's called the 180-degree sprinkler, so that it sprays across the 180 degrees turns. We can get the 270 or 360 degrees sprinkler also, so that it waters all around. Whenever you can't make a spot watering, instead of putting one pipe into each and every plant, if you want to water a specific area, this is how you can use. This is very easy to connect. The same principle, instead of a drip emitter, it will connect to the sprinkler. This is called the mini sprinklers.
That looks fantastic.
Yeah. Yeah. It looks good. But just that I really want to avoid water on the leaves, and especially when the weather is very hot, watering on the leaves will create the scalding to the leaves. It's like whenever you have a dosa pan and then you put droplets of water, the kind of sizzling it does, that's what happens to the leaves, and it's not very good for the leaves. So only in occasions where you can't really make the drop watering, that's where we will use this. Okay, so I have, as we are sending the water to through the entire irrigation system, what if we are able to send the fertilizer also, right? That would save a lot of effort. I have a calendar schedule. Every 2 weeks, I get a reminder that I need to fertilize the lands. At that time, I come here and I use this device. This is called a fertigator. It's a simple device wherein I fill in the my fertilizers into this particular tank. This is the AgroThrive. This is the general purpose fertilizer. It's a completely organic fertilizer. I mix this fertilizer into this particular tank. All that I have to do is insert this particular foot valve into the tank and then change a little bit of connections. I'm going to use a bypass valve. Otherwise, the input to this one is a regular water. The output to this from here gets into the into this particular system. So this system is going to just pull up certain amount of nutrients while it's taking the water. So it's doing the mixing inside the nutrients versus the water, and then pumps into the entire irrigation system. So without this, I have close to about 1,000 plants. So I have to go to each and every plant and apply the fertilizer. That would take at least 2 hours for me. Now, when I use this one, in a matter of 15 minutes, my entire garden is fertilized. And within that 15 minutes, I'm not requiring to go all around and fertilize. I just have to sit here, mix this, and then run the system, and then it will fertilize the entire garden. So this would cost close to $150, just this device and a few of the plumbing units. So with this, my life will be completely saved with the amount of time that I can save with the fertilization. Normally, with all these activities of fertilizers, you will end up ignoring this fertilization, and so you may not get the healthy plants. So this is a very useful device. Any questions so far?
That's a lot of time savings. once you
Of
automate
course,
that.
yes. Yeah. Right, right. Yeah. Let's move to the shade. So we talked about the controller, which is the ratio controller. We talked about the solenoid valves. I have the complete list of material where you can find these units on Amazon. And yeah, the setup is very simple. So it's all about Lego bricks. Wherever you want to take the water, run the pipe, use connectors like a elbow connector, T connector. Can you see this? This is an elbow connector. This is a T connector. And if you have to make a joint between two pipes, this is a straight connector. These are all half-inch versus the 1/4 inch connectors. These are the 1/4 inch connectors. If you want to make a T connection to these 1/4 inch pipes, you could use that. These are the barb inserts. Right. So we can open it up for questions, Lata.
Yeah, sure. While you are on that controller thing, does the controller also manage the water pressure, Shashi?
No, no, it doesn't manage the water pressure. So
Okay.
At the location where we have the output coming, that's where we add the water controllers. It's called the PRV, pressure regulating valve. The typical city water is about 60 psi. Outside the home, it's close to 100 psi. In the basement, or wherever you have the water coming inside your home, you will have the pressure regulating valve. It will bring from 100 to 60 psi. But anything that gets into the drip, it should be under 25. So 25 psi is the pressure that the drip system would take. Otherwise, the entire plastic would blast up because it can't take that kind of pressure.
I see. Okay. So another question Shri is asking from our Zoom is, do those plugs get clogged up when you bury them down for pot irrigation?
No, they don't. They're highly engineered plugs, and then it's not a straight hole for them. There is a circuit inside, so the water gets pushed out, and there's no material that gets inside, and so they don't get really clogged.
Okay, great. Also, another question is, if we have a rainwater barrel, can we use the water from this to drip irrigate our plants?
Yes. So here we haven't used any pumps because there is a pressure coming from the city water. But in case of a rainwater barrel, I can show you the rainwater barrel here. I haven't connected it to the drip irrigation system. You see these rainwater barrels? These are 275-gallon barrels. At the bottom, you have the 2-inch connection. The water pressure that gets out of this varies within the system itself, because when the water is at a very high, the amount of pressure would be high compared to when the water is low. So that's why you cannot ensure that your drip irrigation system works well. So you need to have a pump which gets connected to this system, to this output, and then connects into your drip. So the idea is for you to operate the pump at a periodic interval instead of opening up the solenoid valve, which we have seen in the system. We can also look at a pressure tank that gets pressurized all the times. And whenever you open up a solenoid, it lets the water, otherwise it just closes. So instead of a pump, we can use the pressure pump. So I mean, there are multiple options that we could use for rainwater. I'm going to connect this rainwater to the drip irrigation system so that whenever I have water in the rainwater barrel, I will use this water. And as a backup, I would use a city water.
I see. Okay. And how much time is the irrigation system supposed to be turned on for it to water?
Instead, we should look at how much time it's taking to raise the moisture level to the desired level. So it all depends on your soil. So if it is a complete clay soil, if it is not holding the water gets drained away. So which means that you will end up watering more, but then you will not have enough water within that. So you have to first ensure that your soil is good in terms of good drainage versus getting clogged with or getting drenched with a lot of water. Typically, I use it for about 15 minutes, but then you can start with 15 minutes and increase or decrease based on how the watering system, or if your soil is too much wet, within 15 minutes, you may reduce it. If it is too dry, you can increase it.
I see. Okay. And what is the maximum length of quarter or half-inch tubing that you can use before the pressure drops?
At a 25 psi, you can even go up to 500 to 600 running feet of half-inch, and that's just carrying the water. And every connection of 1/4 inch, you should limit up to 30 feet, so that within 1/4 inch you don't have a length more than 30. Otherwise, you will see the water pressure dropping.
I see.
I would say 600 maximum feet for a half-inch, and 30 feet for an individual 1/4 inch.
Okay. Also, is a 1/4 inch emitter pipe enough for a 8x4 bed?
Yes, that's more than enough. 8x4 is nothing but 32 square feet. So you're picking up water from the half-inch tube and running a 32 square running feet of, I would say 32 running feet of 1/4 inch. So that should be good enough.
Okay, great. I'm going to switch to our YouTube questions. We have people watching from YouTube too. So what is the circle thing that you were showing up in that bed? Does it come in different diameters?
No, this is what we can prepare it ourselves. This doesn't come as a circle. You get a three tubes, and then you will just make a circle of your own diameter. So I just connected using a T connection, the circle.
Oh, I see. Okay.
So you can make it up to any dimension you want.
Okay, great. And going back to the controller, what is the name of the controller that you were showing us, Shashi?
That's Ratio, RACHIO, Ratio.
Okay.
So Ratio controllers are like iPhones of mobile. So they're expensive. They have a specific quality. Not everybody may like the spend in versus what they get, but I like it from the features that it provides.
I see.
And you have other controllers from Rainbird, Orbit, and many other brands that are available.
Okay. Was that the one that the list that you sent us, would that include that information as well? Okay. Okay, great.
Yes.
And would you recommend a split or a multiple water source for a larger area?
If you have an option of rainwater harvesting, you should have multiple sources. Have rainwater harvesting as the primary source and city water as the backup source. There has to be a little bit of engineering to be done to switch seamlessly between these sources, because the system needs to understand when the water is low in the rainwater barrels and switch on to the city water. Otherwise, if you're okay with manually doing it, it will be a simpler exercise.
Okay, all right. And then again, a question on pressure. So what would be the pressure variation for a long area? How long would a half-inch handle from city faucet?
Half-inch can handle even beyond 600 feet, but then we would suggest to have the maximum length of 600 feet. Instead of the length of the half-inch pipe, you should look at the number of emitters that you are pulling out from the half-inch pipe. Let's say you're running a 2,000 running feet of half-inch pipe with only less number of emitters. Even 2,000 running feet will work. If you're running a 200 feet of half-inch pipe, but within the 200 feet, if you are taking up multiple outputs at 1,000 to 2,000 outputs, then the pressure will drop. So we'll have to really calculate based on the number of outputs that we are taking out from this pipe.
Okay, all right. Shashi, do you have
so
more
for any
to show
general,
us? Go ahead.
No,
go ahead.
we're good. Yeah, so in a very general home setup, your half-inch pipe is more than enough with our city connection and pressure at 25 psi.
Okay. Do you have more to show us, Shashi, or shall we go ahead and continue with our questions?
Yeah, please go ahead and continue with the question. So we have covered all aspects of piping, controllers, and automation, fertilization, everything that is required for the home garden.
Okay, all right. So we have a question again from Zoom. Does a machine use fixed amount of fertilizer to mix with water so that you don't over-fertilize?
So first you have to mix the fertilizer into a stock tank yourself. So which means based on the fertilizer that you're picking up, the fertilizer manufacturer would provide a recommendation of how many ml of fertilizer to be mixed with the water. but you have to mix it at a higher concentration because you're on top of it, you're mixing into the water. So the machine can have the variation between 10 to 40%. You can dial in that variations, which means that you wanted to have 10% of nutrient and 90% of water, or 40% of nutrient and 60% of water. You would be able to dial into that particular system.
I see. Okay. And for a garden with around 200 square feet, what items are needed? Any calculations around that?
No, all the list of items that I've given in, that you would be sharing with them is what is required. The length of the pipes have to be measured. So 200 square feet, if it is, it can be of multiple configurations. The length of the pipe requirement has to be measured by the individual because that depends from the distance from the faucet to the actual garden, and then within the garden, the amount of loops that it's making. So that's how you calculate the length. And then individual bags, that's the 1/4 inch pipe calculation. So the list that I've given would give all the material list, but then the individual length measurements have to be calculated.
Okay. All right. Sounds good. And for those of you watching, we are going to, yeah.
On site.
Go ahead, Sandesh.
So how do you close the 1/4 inch pipe as well as the emitter, like the end when it's done?
So this loop is nothing but the entry and the closure itself, right? So you have the 1/2 inch and you have 1/4 inch getting inside, and the water that is going inside this, it doesn't have to go one way. The water splits here and then goes all the way. So it's a complete loop system. So the additional water is getting back to this. So at the end of it, the closure of this 1/2 inch is there using this loop connection. This is the closure. You do this, you make a twist. This is how you close it. So just by making this sharp bend, the water gets stopped there.
Okay. How about on the 1/4 inch?
1/4 inch.
If the drip is on a linear line,
yeah.
At the end, how do you stop it?
Same thing. So if you can just close it and just put a zip tie, that closes it at the end itself. Normally for all 1/4, I try to put a closed loop system so that it gets back to the tube again. But in all the systems, it may not be possible. Let's say if you're taking from all the way from here to the to 30 feet length, and then you don't have a way to come back, you can terminate the connection there just by folding it and then putting a zip tie there.
Okay.
All right. So
yeah,
what
you can go ahead with other questions.
Okay. So what system do you recommend for in-ground plants?
Whatever system that I've shown exactly works for all types of plants. So the grow beds that you have seen, that can be equated to an in-ground plant. So there's no difference between the grow bed and the in-ground plant.
I see.
The same 1/4 inch, same emitter tubing, everything same.
Okay. All right. And can you use this system to spread compost tea that we make at home?
Yes. So whatever nutrients that you give in that particular tank, it would take it to the plant. So it could be any nutrient that you can make, let's say compost tea or the nutrients that you buy from outside. Whatever nutrients you provide, it will take it to the plant.
I see. Actually, I had a question. So in the fertilizer that you were showing us, the fertilizer is a liquid fertilizer, or is it comes in grains like we normally see?
What I'm using is a liquid fertilizer, but you will also find a lot of granular fertilizer, which is water soluble. So you have to ensure that it is completely dissolved in the water and doesn't leave any sediments. Otherwise, it gets clogged.
Okay, I see. All right. And is there a benchmark that we can use to determine the number of 1/2 inch runs we need to have the city water line?
Not like a benchmark. As I mentioned earlier, that depends on the length of your garden or the amount of loops that you have to make within your garden to reach to the final plant. So that goes as a typical planning. If you have a garden layout, you would be able to make it on a paper and then make the end-to-end of 1/2 inch tubing run. And as I mentioned, you can go up to 600 feet. So beyond that, it may drop the pressure. And also because of the length of the tube run, not the pressure, but the volume of water may also decrease because of the friction within the tubes.
I see. Okay.
I have one more question on site.
Sure, Sandesh, go ahead.
So these 1/4 tubes, if I'm running it on, say, a 4 feet wide bed in parallel to each other, how far should they be?
Every 1 feet would be better. So every emitter, let's say, if you put up an emitter here, you can imagine that it would cover 1 square feet. So 6 inches from here, emitter to this side, and 6 inches this side, or I would say 6 inches diameter, 6 inches radius. So that's how you could plan. So a simple mechanism would be 4 by 8 garden bed is 32 square feet. You would run 4 lines of these emitters in a loop. So you don't need to cut it at the end. You just run it in the first 6 centimeters, 6 inches, and then get back with a distance of 1 feet between the tubes. So you will cover in 4 lines, a 4 feet bed.
Okay.
All right.
Kelata, go ahead, please.
Okay. And how many emitters can we have in the 1/2 inch of 200 feet?
It can be as big as 200 also. So every 1 feet. Instead of number of emitters, okay, so if you're just putting up an emitter just to get the water source out, you're talking about 1 emitter. But if you're putting up a system like this, though it is 1 emitter here, but it has almost close to 1, 2, 3, 4, 5, 6, 7, 8 emitters within this loop. So the number of these emitters is what you have to really count, because that depends on the amount of water it's dispensing. So within a 200 feet, you could imagine every 1 feet, 1 emitter getting out, and at least 10 of them. So 200 into 10, so about 2,000 total emitters is what you can plan. These are all the rough calculations. So mostly you will figure it out the moment you see the pressure drop. But I haven't seen any case wherein within a home system, for a 1/2 inch or a 1/4 inch, there was never a pressure drop at 25 psi regulators.
Okay, all right. That is all the questions that I have. And what we're going to do is, while we wait for some more questions to pop up on Zoom, I'm going to go ahead and share my screen and talk a little bit about other green cell projects. Shashi, this was a very engaging and informative session. It was very, very informational. So let me go ahead and share my screen, and we will talk about our other projects that we do.
Lata, I have one more question later.
Yeah, go ahead.
Okay, so I wanted to ask about leaks, especially when you are poking the hole on the 1/2 inch, and you're getting the 1/4 connection out of it. Does it eventually leak? And if it does, how do you fix it?
So just to ensure there are no leaks, you have to punch.
Shashi, did we lose you?
Can you hear me now?
Yes, I can hear you now.
Okay, right. So the question was about the leaks. From into the 1/4 inch, if you are poking a hole precisely with this particular unit, or maybe a smaller hole, and insert it hard with your with the barbed emitters, so you would see these barbed connectors have a collar. The idea is that once you try to push it in, it makes the hole a little bigger, but at the same time closes it. And all these tubes, they are made of plastic. Because of the sun, it would heat up, expand, and contract. So that's how it would really hold it tight. So there won't be any leaks. Even if there is a leak, there will be a minute drop, but not a real big leak.
I have one more kind of extended question. If I have a hole and then I take the 1/4 inch out of it, but then I decide that, oh, I don't need a hole here. So what do I do?
So within the material list, you will find something called a goof plug. That's like a plug that would just stops the particular that hole, and the water wouldn't come from that hole. It's called a goof plug.
That's it from me, Lata.
Okay, great. So again, like I said, we'll wait for our audience. Audience have been sending us some really awesome questions. So we'll wait to see if anybody has more questions. While we kind of collate and wait for more questions, I'm going to talk about our planter row. So our volunteers are participating actively in Alpharetta City's AG Planter Row initiative. Here, the gardeners commit to growing food for the food pantry. This event is local to the North Atlanta suburbs. The vegetable plots are at this venue. So if you do have an organic kitchen garden and are willing to donate excess produce, you can join us. And please do contact us for more information. Geeta, do we have more questions from the audience or from YouTube or Zoom?
There is one from YouTube in
There's
the
one
document.
from YouTube. Yeah.
Okay.
Go ahead,
great.
Pankaj, if you want. What kind of maintenance is required after setup?
The typical maintenance would be any kind of leaks, and some places you would find the connectors would have come out. So whenever it's on an occasional basis, at least once in a week, it's better for you to have a walk around and see if there are any places that got bursted, and then you just fix them. Fixing is nothing but putting up a goof plug, or if you don't need that particular location anymore, or connect it back with the 1/4 inch adapter, which would have come out. Normally, the 1/4 inch adapter is very tight; it wouldn't come out. But the spider emitters at sometimes may come out, so that's where you have to just watch it. And other issues could be if while fertigating, if your fertilizers have sediments and they may end up clogging, so you may end up having the issues with water not coming out of the 1/4 inch emitters. So at that time, you will be able to you just need to flush off the entire system by opening up the 1/2 inch that you would have at the end. Maybe let me show you the 1/2 inch closure. So in my garden, this is the end pipe. So I would just open it up and let it open.
Hey,
and
Lata,
just flush
if
it
you
up
could,
using.
please stop your screen sharing. His video is really small.
Okay, sure.
Go ahead, Shashi.
Just move a little bit, it'll just flush the water. So I'm just flushing it out so that any sediments that are there, that would come out. So earlier it had a system wherein this was a closure. Now I have removed the closure.
Mm-hmm. We've lost you again, I think, Sashi.
You hear me now?
Yes, now, yes.
Okay. So this is how it's going to flush out the water. And any kind of hard sediments would come out. So once you do it for a minute or so, you can just close it up. Switch off the water. That's how you just flush it up.
Lata, there are a couple of more questions. I've updated the question doc for you to see.
Okay, great. All right. Are you ready for more questions, Shashi?
Yeah, sure.
Okay. So the other one more question is, do we need to prepare emitter or we get it directly from the market?
Oh, we just get everything directly from the market and they're quite cheap.
Okay. All right. Can this irrigation be put on a pond water system?
we can do that. Pond water system would have a lot of sediment, so it's important to have the filters before we pick up the water from the pond and then put it into the irrigation systems. Your pond water will also have algae, and so we may have to have a hydrocyclic filters and a few other filters for this. That will become a little detailed activity. Maybe if anybody requires help, we can talk about it.
Okay, sounds good. And is this drip system to be redesigned each year with changes from year to year in the layouts?
No, not. Oh, well, yeah. If your plant layout is changing, yes, you will have to redesign. But then I always try to fix my entire garden layout up front and put the irrigation system. I won't change the layout at all. I would just swap the plants if I really want to.
Okay. And then
it's all flexible pipes, so it's very easy for you to just move them around.
Move them around, yeah. Okay. And is there a guidance for watering on a slope garden using the system?
Yeah, so all these irrigation systems, emitters are pressure compensating emitters, they are called. They are called even if there is a slope, the natural tendency of the water is to get down to the lowest point, but then with the pressure compensating emitters, across the slopes, all the emitters would give out the same amount of water. They are highly engineered, as I mentioned earlier.
I see.
So you don't need to have a different system. You can just use the same system.
Okay. And one of our registered participants had a question. They are using currently rain cloud timers for the lawn. They would like to add another timer for the raised beds.
If it is just one extra timer, and if they already have the lawn timer, they can just use the host timer. It's a simple $30–40 of timer that would get attached to the faucet, and it operates with a battery, and it doesn't require any complex setup. So, but it's just that it doesn't have the ability to connect to your mobile phones or connect to the internet. So even there is a Orbit Beehive, which is about $60, which gives you a single zone and at the same time connects to your internet. Maybe I could pass those details, the material list.
Okay, all right, that sounds good. And any recommendations of installers for if you're not a DIY customer?
So I offer the consulting, remote consulting. I do not install, but I offer the consulting on architecting the gardens. And at the same time, if it is a large project, we can talk about it.
Okay. And how long does the system last? Do we need to replace these every year or 2 years?
No, these tubes are, they really last very long. I haven't lost anything for past 3 to 4 years. So it just lasts long.
Okay,
They
great.
consider it to be 3 years, but then they are very inexpensive for even worrying about replacement.
Right, right. Because it's constantly getting exposed to the sun, right? So you might have
That's
to
right. Yeah, yeah.
Yeah, okay. All right.
I have one more question here.
Go ahead, Sandesh.
Is it advisable to bury the 1/4 inch line underground where possible?
Yes. So, but don't bury it so deep. If you don't find it, you may end up digging it. But if you are able to mark it, it's better to have a couple of inches buried inside so that it's not exposed to the sun. And the same thing to do with the 1/2 inch tube also. So I tried burying everywhere where it's possible, but I just want to ensure some places are open so that I know there is a pipe there.
Okay.
Any questions?
I think we've covered a pretty good amount of questions that have come through Zoom, YouTube. Geeta, do we have anything on Zoom that the
No,
participants
nothing
have?
else. Nothing.
That's it?
No more questions on Zoom at this point, Lata.
Okay, great. So I'm going to start sharing my screen again, and then we'll kind of, close out our webinar. So thank you, Shashi, again for this wonderful session and answering all the questions that the audience had. We greatly appreciate it. Very, very informative. I'm sure the participants enjoyed and getting to know how to automate their garden. This was wonderful. So please visit our website, Facebook or Instagram page at Green Cell Atlanta, or to know more about our upcoming events. We also have our YouTube channel where we can find past recordings of today's webinar as well as earlier webinars. So, and if you would like to donate, if you'd like to donate towards our cause, you can find the donate button in our website. We would also like to request everyone to fill in a 1-minute survey to let us know how we did. It really helps us get better for our future webinars. And they'll put that survey link in the Zoom chat also. And our next webinar is on July 11th with Pankaj. And this session will be focusing on recycling right. Looking forward to seeing all of you in the next webinar too. Good evening, guys, and have a nice day. Thank you so much for joining us. Bye.